thank you everybody for coming. Super excited about this discussion. Excited to present with Daniel and Bhaskara from CBS. Very cool story, how they migrated off of Teradata into BigQuery and GCP. Before we get into that awesome story, Bhaskara has given me 3 minutes of permission to talk about some of the cool things coming out of BigQuery. So, does everybody know what BigQuery is? I see a show of hands. I can kind of see. I'm not going to really go into this. Okay. The only thing I like to call out is that it's serverless, right? It's a fully managed and serverless environment to do your big data analysis. And again, one of the cool things that I love about BigQuery is we want to take care of all that operational annoying stuff, and so that you guys can focus on running your queries and running your analysis, and we take care, that's what that serverless thing enables you guys to do. So we can do that heavy lifting, so you guys can do all the fun stuff and get insights out of your data. So BigQuery's been around for a while, and it's a very powerful tool. It's a very powerful platform, and what we've been weak in the past is helping our customers migrate into BigQuery. And so, we like to call these the on-ramps, and we have very weak on-ramps until now. And just recently, if you guys have been following some of the announcements, we just launched a data warehouse migration service. And so that includes 3 different services. One, Teradata migration, which is awesome. We'll talk about that a little bit. For the next CBS, hopefully it makes it a little easier and a little faster for them to migrate into BigQuery. So that's in beta. If you go to the console and you click on the data transfer service, you can actually migrate schema and data pretty seamlessly into BigQuery. We also launched a Redshift migration service, which is an alpha. So if you guys want to reach out to your customer service or your partner or your account executive, we can whitelist you for that. And then S3. So you can, if you have data in AWS, you can put it in Parquet files or Avro files in S3, and we can automatically load those into BigQuery. So super excited about this service, and again, hopefully, if Daniel and Bhaskara did this again, it would be a little bit easier for them. So with that, I'm supposed to get off the stage now, but I'm really excited to introduce you to Bhaskara, and take it away.
Hello, everyone. From CBS Interactive, I have Dan, and I will come into the stage in a few minutes. But I'll first go over some of the high-level details of the migration. And these are the topics that we are going to cover today. Trust me, this is not a sales page. I just want to give you a high-level idea of CBS Interactive, what we do. To give you some sense of scale and background on CBSi, we are the largest premium content company and ranked at number 7 per Comscore report. After YouTube, we are Google's largest ad partner. And within the verticals we serve, our brands are leaders and number 1 in all categories outside of sports, where we trail only behind ESPN. And CBSi is well-positioned to be the network of the future. And we have reach across TV, entertainment, news, sports, and more local news live streaming. Huge growth for us in connected TV space and OTT platforms. Before going into the details of today's topic, I have a quick question for the audience. How many of you are actually planning to migrate to the cloud? I don't know if I can see everyone, but I could see some hands rising. So it's good. So first I'll show you the platform that we have before the migration. And at a high level, this is our infrastructure footprint. And if you look at it, we have 27-node Teradata cluster with a 120 terabytes disk space and 22 Hadoop nodes of 1 petabyte disk space. And also we have 6 CPU Informatica server. We have automation engine, Tableau, which is our reporting, BI reporting and visualization tool. And we have data products wherein we create custom dashboards which cannot be done through Tableau. So this is our footprint at a high level. And if you look at the data flow, the data we acquire through internal and external APIs and also internal databases. We acquire into HDFS and also NFS and process through Hive and Teradata. And we also copy most recent data from Hive to Teradata almost daily basis. This is mainly because of the database constraints we have, size constraints on Teradata. And also, if you look at Tableau and other data product applications, we have the choice of querying either Hive or Teradata. So there's a flexibility our analysts have. And if you look at some of the challenges that we are having, scale. If you're familiar with database appliances, it is not easy to increase the size without going through a lot of effort. It requires a lot of money, resources, and it's not easy. And same thing with Hadoop, we have to plan a lot. And if you look at SLAs in the past, we had frequent delays in SLAs, and sometimes we were delayed by 4 to 6 hours. And for us, the data is critical because ours is a media company, and we are not short of major events. We have major events throughout the year, starting in January all the way to December. And we start with the CES, and then March Madness, Super Bowl, a lot of news events, and a lot of other all-access original launches, and a lot of other events. So there are a lot of problems with the SLAs, so that's one of the challenge. And SQL, I'm sure some of you also might have in your companies. We have few users who could bring down database to its knees, and of course, it is not by intention. Even everybody writes inefficient SQLs at times. Even I did too. So whenever those inefficient SQLs are going into Teradata, the performance is going down. And then we do the backups almost every week. And whenever the backups are happening, the performance is degraded. And every Monday, we have always constantly has to monitor how the reports are coming along, because we have seen most of the delays on Mondays. And also, the concurrent users, if the number of users are increased on the system, it is typical with some of these appliance databases that the database performance will go down. So these are some of the challenges that we were having. And right around that time, there was a company-wide cloud-first initiative, which helped us to actually start thinking about cloud migration. And also, CBSi and Google are good partners. We have been using Google's products. For example, we have been using DFP, which is Dot for Publishers, and also G Suite. So it was a natural evolution for us, and it was a right fit to start looking at Google Cloud, and that is how we started our migration. So let us see how we actually did the migration. We considered a few options for going into BigQuery. So option number 1, it is migrate only data to BigQuery. And option number 2, migrate entire platform, that meaning infrastructure, processes, data, everything to cloud. However, this option number 2, sounds good, but with the given time and resources, we thought that it is not possible to do it. So we looked at a middle ground, which is option number 3. So now let us look at what that option 3 is and what are some of the details of option 3. So migrate data to cloud, meaning wherever the data is processed, we have to have the data in the cloud. That way, all the users will have access to one single database for their analysis. And second, big data. So we thought that by processing the big data in the cloud will help us a lot, because that is where we have most of the challenges. And we tackled that first. And when I say big data, mainly around clickstream data, which is the web traffic and ad impression data. And also, there were no technical constraints for us not to migrate the processes into the cloud. So it made us easy for making the decision. While we did that, we also changed the data structures for these big data sets, and that helped us a lot with performance. And of course, we did this in consultation with a task force, which was formed by inviting some of the key stakeholders from our businesses, and that worked out pretty good. And I'll give you some more details later on. And also, if you look at the dimension processing, it is not, while BigQuery is very good and high-performance database, we cannot do traditional or the DMLs like we do with traditional databases. Whereas Informatica process that we had a lot of inserts, updates, deletes on a daily basis. So we couldn't do that. So we looked at Informatica replacement at that time. However, we couldn't find a good replacement. And also with the given time and resources, we decided, OK, we are going to keep Informatica for now on-premise. However, copy all the process data to the cloud, because ultimately the goal is to have all the data in the cloud. We also decided to keep all the Hadoop jobs on-premise. However, we made a simple change by writing the output files not only to Hadoop, but also to GCS. And this gave us a leverage to reduce the time of migration. Also, at the time of decommissioning Hadoop, it made it easy for us. Data product applications, we decided to migrate the application code first while keeping the Teradata on-premise, because while the code is in the cloud, the applications were talking to the database on the premise. So we did that because we wanted to make simultaneous progress with multiple, I would say, lanes in our project. So those are the decisions we took. And likewise, the BI reporting servers, we kept them on-premise. This is also purely because of time. Otherwise, there is no technical reason. So that also we kept on-premise. And the next one, I'll show you the timeline now, how all this migration took place. So we started March 2017. That's when we started planning and then started looking at all the new tools and technologies, because we are going into a new platform, brand new platform, and we need to evaluate what is out there and what we need to do with all the new tools. So it took us about 6 months, and by August 2017, we were actually ready to start migrating or start working on the actual code. So from August through January, we have migrated the code that is required for the first business unit. So by January 2018, our first BU is ready to go live. And as you can see at the bottom, it took us about 11 months for the first site to go live, which is amazing. And then by May, we are live with all the business units in BigQuery, and all of this took 15 months. And then if you look at July 2018, that is when we shut down the Teradata. So we kept running the Teradata between May and July for about 2 months, just as a fallback, in case if anybody has any doubt or anything, they can always go back. But in July, we started shutting down the Teradata. And between July and December, we converted Hadoop jobs. And then by December, we were able to shut down Hadoop. So all this has happened like over 22 months. And as you can see, we have supported 3 different data platforms over an extended period of time, which is not easy. And also, we had to migrate this data over many, many brands where the priorities are different for each business unit. And also, we did all this with a team of 8 dedicated engineers with some help from other engineers across the company. And it was a great team effort, and we have an excellent stakeholders who have helped us with a lot of testing early on, and overall it was a great team effort. So now I'm going to hand off to Dan, who will talk to you about some of the technical details of the migration. Dan?
Okay, so I'll cover the Google Cloud architecture that replaced the on-prem systems that we're retiring, the migration strategies for our big data acquisition jobs, our ETL jobs, and our historical data, and the technical challenges that we encountered during the project. So the scope of the project was to retire Hadoop and Teradata and move our data products to the cloud. So Hadoop and Teradata are going to be gone. So what do we replace them with? So for the big data acquisition scripts, they used to write to the Hadoop distributed file system because we needed a large distributed file system to store it on. So we replaced that on the GCP platform with an Apache NiFi cluster that we set up on the Google Compute Engine, and it would write its data to GCS. I'll cover these systems in more detail soon. For our big data transformation jobs, we replaced our Hadoop MapReduce jobs with Apache Beam on Google Dataflow. For Hive, Impala, and Teradata, they all got replaced with BigQuery. So our Informatica jobs were writing to Teradata. So to replace Teradata, we wrote the results to an on-prem Postgres database, and then we used the Apache NiFi cluster on GCE to copy the data daily to BigQuery. For our big data acquisition jobs, as I said, we replaced it with an Apache NiFi cluster on GCE, and we installed those as Docker containers on Google's container-optimized OS. So the way it works is that the vendor places their data files on GCS every hour, and we have processes, a workflow running continuously in Apache NiFi, listing new files that appear in the bucket, fetching them, doing pre-processing on them, which is mainly decompressing the data, and writing it onto our own GCS buckets for later processes to work on. And the NiFi workflows also subscribe to a pub subtopic that accepts commands for reacquiring data in case there are operational issues. Our operators can issue commands to the NiFi cluster to reacquire data. So for our ETL, that was running as Hadoop MapReduce jobs as Python programs. So we wanted to reuse a lot of the transformation functions that we had on the on-prem systems. So we made a decision to migrate to the Apache Beam Python SDK and run it on the Google Dataflow service. So in order to do so, we created agent machines on Google Compute Engine that has our automation engine agent. It's also running on Google Container Optimized OS. So the agent is running as a service in a Docker container and accepts batch job commands from our on-prem automation engine server. And those batch jobs launch a container for each batch job from application images installed on the agent machine. And each of those batch jobs are Dataflow client jobs that issue commands to the Google Dataflow service to run batch jobs to process the data. So it's taking the data that NiFi had placed on GCS, transforming it, and putting the results in GCS. So part of our Google DoubleClick add data transformations is denormalizing the data, looking up 20 fields from 9 tables. We found it was hard to write and maintain in Python in Dataflow. But it was easy to write it as BigQuery queries, just having 9 left outer joins in the query. And in our testing, we found that it ran really efficiently in BigQuery. So that's what we're using in production today. And in the future, we are preferring ELT and BigQuery in most cases, since it's easier to write and maintain. So another part of the project is that we needed to get years of data on the order of hundreds of terabytes from on-prem to GCS and BigQuery. So for data that's only in Teradata, we first copied the data to Hadoop. Once the data is on HDFS, we can use Google's cloud storage connector, and we installed that on our on-prem Hadoop cluster to copy the data in parallel up to GCS. So we installed our GCS, our Google credential files, service account files on our client machines, and then our on-prem Hadoop cluster could write the data to the GCS. And it was extremely fast. If we wanted to, we could have copied all of our data in just a few days. Also, at that time, BigQuery did not support the Parquet file format for data loads to BigQuery. So we created a system that we could write configuration files of Hive queries that for each table that we needed to convert. And those Hive queries would convert the data types and write Avro files on HDFS. And we wrote automation workflows to do daily jobs to write these Avro files on HDFS, use the Hadoop distcp command to copy and parallel the GCS, making use of Google's Cloud Storage Connector, and running the BQ load commands to get it into BigQuery. So for Informatica, we needed to replace all the workflows that target Teradata, since Teradata will be retired. So we couldn't target BigQuery directly because all of those jobs are written as transactional inserts and updates. So what we decided to do is we duplicated the workflows and targeted them to an on-prem PostgreSQL database. It was on-prem because of limitations in the database drivers we had that had write latency issues. So since Informatica was on-prem, the PostgreSQL database also had to be on-prem. So to get it into BigQuery, we used our NiFi cluster on Google Compute Engine. We created workflows that accepted commands from Google PubSub, those commands saying to copy tables from the on-prem PostgreSQL database to BigQuery. And we added those table copy jobs to our daily schedules in our automation engine. We also created global flags in our automation engine for Teradata retirement and added preconditions to our Teradata workflows on those flags. So just by changing one flag, we can turn on and off all of those Teradata workflows. So now I'll cover some of the technical challenges we encountered during the migration project. So as I explained, we're using this complicated system of getting the data into Postgres and then copying it once a day using our NiFi cluster. So we'd like to simplify that in the future. So we've written a library of reusable code for getting slowly changing dimension data directly into BigQuery. And the way the system works is that new and updated records are appended to log tables in BigQuery. And the sources could either be daily batch jobs that append records from recent days, or it could be real-time streaming jobs that append to log tables. And both sources are subject to duplicates. So we wrote this templatized BigQuery SQL that reads from the log tables and creates new versions of slowly changing dimension tables. Two types of those tables. Type 1 for writing the current version of the record to the destination table, and type 2, which is writing deduplicated history records for each key to the destination table. So the main parameters for this library is what's the source log table that we're reading from, what's the key for this table, and what are the fields that identify the ordering of record versions for that key. And from that, we create an order by clause with the most recent record first. So this is the basic template for a type 1 dimension table, writing the current latest version of the record to the destination table. You can see it's making use of BigQuery's array ag functions, ordering by that order by clause we generated, and picking the most recent record. And that replaces the destination table. For type 2 dimension tables, we write the deduplicated history, and we add history fields of effective start and end timestamp of the record. and a third field, which is a flag field indicating whether this record is the current record for this key. So this is making use of the windowing functions that BigQuery supports. You can see we're generating the 3 extra fields I mentioned and getting and deduplicating the records. Another problem way to solve is having atomic isolated data sets for our data flow jobs. So we needed the data processed by data flow to be atomic so that downstream jobs see just the complete output or no output. If a data flow job fails, we don't want downstream jobs to see partial data. And it needs to be isolated. If 2 concurrent jobs are running at the same time, we don't want them to be using the same file names and stepping on each other. So GCS has ACID guarantees for individual file objects, but Dataflow runs in parallel and produces a whole data set of related files, and we need these ACID guarantees for the whole data set. So we created a GCS dataset standard and set of libraries to support that standard. And it uses 2 locations on GCS, a dataset location and an index location. And the data flow job is configured to use the dataset location, each job having a unique ID in the destination. And when the data flow job completes successfully, we write a metadata JSON file that's to the index location that has the logical name of the dataset. And our libraries are written so that downstream jobs can get the latest version of the metadata and retrieves the data set from the dataset location. Another decision we had to make is how to shard our fact tables. So our big data fact tables are all partitioned by day, but we also have distinct subsets of data on a non-time field. For instance, for our Google DoubleClick ad data, we have the event type, such as impression, click, or video conversion. So some queries are only interested in a subset of the event types, and we want to reduce our query costs by scanning only the event type rows needed by those queries. So the system we came up with was to load to multiple tables that have the exact same field schema, 1 table for each event type. And we created views that union all these tables together. So queries can just query the data that they need by choosing the views that they query. Another decision we had to make is about time zones. So our decision was to use BigQuery's timestamp type in our physical tables. So our transformations all convert the timestamps to UTC before loading into those tables. If users need to see data in different time zones, we create a view, the view generating extra date time fields under that specific time zone. And another problem we encountered during our project was providing the BigQuery table schema during loads. We didn't have any problems when loading the fact tables, which is the first things that we worked on. We wrote to the fact tables. They were partitioned by day, as I explained, so we're loading in write truncate mode, replacing those daily partitions. And we didn't need to supply the table schema on those loads because BigQuery preserves the schema for these partition tables. But then we got to the dimension part of the project. As I explained earlier, we're copying those dimension tables once a day from our NiFi workflows. And the dimension tables are not partitioned. So we're loading to these unpartitioned tables also in write truncate mode to overwrite the tables. We found that the table schema was not preserved then, so we just had to change our jobs to provide the table schemas for those jobs. Next, Bhaskara will discuss the Tableau migration and our overall recommendations from the experience we had with our migration project.
Hello again. I'll talk to you briefly about our Tableau migration process that we have implemented. So the first thing what we did, we took inventory of all the workbooks, tables, and reports that we had to migrate. And as you know, for any company over a period of time, you will create a lot of reports which would be unused, once you take about 6 months or 1 year or many years. So we took time to identify those unused workbooks, tables, and everything, and we took them out of the migration process, and that helped us with the migration time as well. We also took the priorities from our stakeholders, which is very important, and also the conversion was done based on the priority given by the stakeholders so that they understand when the tables are coming for them to work with. And the last thing is, getting the review and sign off by the owners is also critical. Next, let us look at the conversion steps of the Tableau workbooks itself. As you can see, this is like I hope you can see the picture well. This is like an assembly diagram. So, assembly line. You create a new data source with a BigQuery connection, and then rename the columns, same as existing data source. Copy the calculated fields to the new data source, and replace the old data source with new BigQuery data source. And then the last step is validate. So it's like an assembly line. You repeat this for each and every workbook. And now let us see some of the challenges that we faced during the migration. So for Tableau conversion, what we did, we have migrated some stale data to cloud to help with initial conversion. We did this mainly because we would like both the migration and also Tableau conversion go in parallel so that we are not waiting on one another. At the same time, make the progress with the project with the given timeline that we have. But because of that, we had to validate some of the reports twice, but I think that's okay. We couldn't avoid it. And then as we are doing the migration, business is not going to stop because they'll continuously create the reports. And it was a challenge for us to keep up with all the new workbooks that are being created and then bringing them into the conversion pipeline and then plan the conversion. And that added some timeline for us, but it was a challenge and we were able to mitigate that. And then if you look at converting all these workbooks, it took some time for us to get a hang of it. What is the best way to migrate in a quick way? So it is like extract, convert the Tableau, owner review, and then rinse, repeat, sign off, like it is a assembly line as we talked before. So I'm sure some of the users, some of you might be looking at Tableau migration. So I would like to talk to you about some of the tips about the Tableau migration that might be useful for you based on what we thought. So if you are using custom SQLs in Tableau conversions, make sure to include the workbook name as a comment as the first line of the SQL. And this will help you a lot in identifying any SQLs that you would like to tune further and identify what is the workbook name and everything. And one way to identify is going through the audit logs. If you go through the audit logs, you can only look at the SQLs that are running, but not the workbook names. So that is the way you can get the workbook name. Pardon me, David, for saying this. I hope you're okay with me saying this. A big no-no for using select star on any of your largest tables. You will get to know it pretty quickly once you start using BigQuery, and that is so, especially because if you are coming from a traditional relational database, because that is how we got to know. Because the costs are going to be pretty high if you are using select star on large tables. Because the cost is based on the amount of data that you are scanning in the query. And there are some standards that you have to follow for Tableau conversions. For example, for column aliases, you have to use only letters, numbers, and underscore. And Then it should start with a letter or underscore only. And the date format that BigQuery accepts is in a specific format, YYY And now I would like to show you some of the experiences from the stakeholders, what they said about BigQuery now that all the migration is completed in their own words. These are all self-explanatory, and as you can see, they thought that it is kind of a self-service platform because they were able to automate the queries by themselves. They were able to create the summary tables, without asking for any help, and also they were able to share the queries across the project repo, which is a great feature that they loved it. And then, BigQuery, all the heavy lifting was done using BigQuery, whereas they were only looking at smaller data sets when they're working with Python notebooks. That's also another great feature. And also, it's a significantly faster processing, according to what the stakeholders have said. And they were able to work with the truly big data because in the past, when they were running atomic queries, sometimes it is taking forever in some of the databases. But now they're all getting the data in a very, very reasonable time. In some cases, within a few seconds and minutes, which is great. And also another thing, what we did, we empowered the stakeholders in some cases. We gave the ownership of the projects to some of the key stakeholders. That helped them to be self-sufficient in what they would like to do. And they're pretty happy with it. And also their team was able to do a lot of things without getting any help from other central teams. And also, as we discussed before, we migrated the atomic data wherein we introduced the array fields. And then these array functions actually helped us with improving the performance on the queries and also reducing the cost on the queries that we are running on the atomic data. And also, it has simplified the code from few pages to few lines of code. This is a great feature. And if you are having any large data sets and if you can introduce this functionality, please do so. And also another interesting feature that the customers have liked was integration of Google Sheets with BigQuery. And this one was definitely liked by some of the stakeholders in our company. Now let us look at some of the big wins for us. What are the big wins that we have seen? As you have seen in the previous slides, happy stakeholders. What else we need? That's all what we are all striving for. We want to make the customers happy. And that's what happened with the BigQuery migration. And significant improvement with the SLAs. And we have seen a lot of improvement. And also for Super Bowl 53, just a couple of months ago, we were able to process the largest data sets during that event without any problem, without any limitations on the database sizes, which is great. And our operations team, they were able to reduce the footprint of the data center because we were able to shut down Teradata and Hadoop. And then our engineers are able to focus on the real problems rather than some of the day-to-day issues that we have been seeing with on-premise infrastructure. And also, we were able to reduce the number of tables from on-premise to cloud. We were able to reduce, I think, at least about 50% of the tables we were able to eliminate. Because, as I said before, over a period of time, you create the tables and we never use them because the functionality have changed or the project got dumped out and nobody's using it. And we never know that. So we took time to identify those tables and then remove them from the migration. And reduced dependency is increased productivity. And that's what we have seen with the cloud migration because everybody was able to do a lot of the tasks on their own with less dependency on the central teams. Now that we are coming to the end, I would like you to leave with some of the takeaways that we learned from this migration. Probably they would be useful for you if you are planning of migrating data to the cloud. Training, training, training. And don't get us wrong, we did train our engineers, but at the end, when we did the retrospective of the project, we thought that we could do much more training for our engineers. And also, if you are working in a small team, make sure to cross-train your engineers across different products, and that will help a lot. And also, if you can, train on your own company data rather than using Superstore data, because the analysts will get early on hands-on experience with your own data. And since you're migrating into a new platform, new software, new processes, make sure you have that feedback loop to identify the improvements that you need to make on the new processes that you are implementing. Because sometimes we ignore that, but I think that's what we have seen. It's always good to have that feedback. And the task force. So this is something that worked very, very well for us because they're invested into the process, and they have been working with us, and we are working with them all along throughout the migration to make any major decisions around the cloud migration. And they're happy to be part of it, and it helped them to know how things are changing and how they should be prepared. And also, it helped them to get early access to the data and also help identifying the issues early on. And then take time to discover and retire any obsolete processes or tables, even though sometimes it is time-consuming because it took some time for us to go through all the logs and everything, but it will help you in the migration time and the overall process so that you can remove the clutter in the new platform. The next one is try to migrate most recent data to the cloud first. In our case, that is what we did, and it helped the analysts to give early access to the data, and also they were able to play with our own data in the cloud and help us to give us the feedback on identifying the problems early on. That is a great thing that helped us. And when we did that, we also copied the dimension data to the cloud so that they can get the entire data set to play with. Query cost. This is very, very important. And even now, we have been seeing some of the areas where we can improve in our company. But what we did, especially with our cloud migration, we have created some alerts early on to alert us if any query, if anybody is running a query, that cost, the cost is exceeding certain limit, we'll get an email or alert. So it's like a training the users to tell them, hey, this is the query you ran, and this query costed you $1,000. And so please be mindful because we had queries when we started working with BigQuery, there were users who ran the queries worth $8,000. You may not believe it, but that is true. But pretty quickly, we were able to contain that, and then everybody now is able to run the queries very effectively, and those alerts helped us. And even we are continuously improving on how well we can improve that process. And also, our strategy with Go Live is sequential. And that helped us a lot because it gave us momentum. Once we go live with first business unit, it gave us the momentum for the rest of the groups to go live because they have seen other people, other business units going live. And that helped us and also them. So that's what I would suggest. If you have many, many brands, that's what I think you can take that approach. And as you have seen, this is a very, very complex project over many, many brands with a lot of different priorities. And we have a great team and excellent stakeholders, and that is how we were able to do it. And that's all what we have. And thank you for joining our session today.